Hello everyone, let's talk about an easy problem on Leetcode today. Isomorphic string, Leetcode 205. Easy problems are generally asked in the interviews, in the screening rounds, and they do just have some edge cases and some important concepts. Um, let's go through the problem. So it says given two strings s and t, determine if they are isomorphic. Two strings s and t are isomorphic if the characters in s can be replaced to get t. So let's see, then it defines it further. All occurrences of a character must be replaced with another character while preserving the order of the characters. Um, no two characters may map to the same character, but a character may map to itself. I think the best way to understand this definition is to go through the example. So first example, it says S is egg and T is ed. So we can see that in this case, E maps to A, then G maps to D. And then once it's mapped, it cannot be remapped, right? That's the main concept. So once we do it G again, we again get a D. So in this case, the string is isomorphic. Then they gave a very good another example, negative example, which is foo and bar. So in this case, we see that initially f maps to b, which is okay. Then maps to o maps to a, right? And then again O maps to R, which is wrong because once it is mapped, we cannot remap it to A. So that's what the definition says. And then there's a bigger definition, a bigger example with paper and title, but we can see that P maps to T, A maps to I, then T again, P has already mapped to T, so we get the same character, and then E maps to L, and then R maps to E. So in this case, again, it's a, isomorphic string. So now that we have understood the problem, let's get into the solution space. Now let's look at the solution. As we have the map between the two uh, characters of the two strings, I think we should use a hash map. That's what the solution is hinting to. Uh, and what we can do is we can create a map between characters of the first string to the second string. So and then once we find the character which is already mapped, then we can say that okay, this string is not isomorphic. Otherwise, we will just continue. So let's look at an example here. So we what we can do is like we can first we will iterate over the first string. Say first character is E, and once we find out E, we will see that okay, the E is empty. So that means we will put it in E, like sorry, our map is empty, and E is not found. So what we can do is we will just add E to the map, right, and map it to A. Now next character is G. G is also not present in the map, so we will again put it into the map, and now the character becomes maps to D. Now again we get G, and this time we again check if G is present in the map. Yes, the answer, we have these two characters already, so G will be present. So what we will do is like we will check, we will get the value for G, and that is D, and that should map to D in T, which is matching. So in this case, yes, this string is isomorphic. Now let's look at another example. In this case, it's foo bar. So again, what we will do is like we will have f in the first character, then we will map it to b in this case, right? Then we get o. Now o is mapped to a. Now again, when we get next character is o, we will check yes, o is present in the map, and the value from it we get from the map is a, right? And but in T, the value at which we are getting at the second point is R, and that is not equal to A. So in this case, the string is not isomorphic, and and that means this here we return false. Now let's think about, is one hash map enough for this solution? And let's see why we are thinking about it. So in this case, what we can do is like we can say that okay, let's take the character S is apple. Of course, it's not present in Leetcode, but just sharing it out as an example. And this is what the tricky part of the solution, I think, is. And then C, T is BAABC. This is a just totally made up string. So when we now iterate over the map, we will have A mapped to B, right? Again, P mapped to um, A. So now again we get P, but this time it's already mapped, right? So we will check what is the value we get from the map. That is A, right? And what we have in the T is also A. So that matches. So all is good. Let's continue. Now we have another character as L. So we map it to what you say B, right? And then we map E to C. But still, as one of the points of the definition was like once the character is mapped, it cannot be remapped. So in this case, what we have done is we have remapped B in T to L. So this is not correct, right? Now let's look at the proper way of fixing this bug in our one map solution. So instead of now we'll be using two maps. That is that we will map the characters from string S to string T and also do the same for characters from string T to string S. So let's again walk through the example. So first character that we get in string S is A, right? And in this case, what this will do is like we will map it because the A is not present in the map. We will map it to character B. And likewise, what we will be doing is we will be mapping character B to A because B is not present in the second map. Now we get the character P in the first string. We check if P exists in the map on the key side, of course, and the answer is no. So we will map it to A in the second string. Similarly, we will check if A exists in the second map, and the answer is no. So we will map it back to P in this case. Now, when we get P again, we will check if it exists in the map, and the answer is yes. And the key for it is A, right? And what we have as a string in T is uh, A, so it matches A, so all is good. Um, and likewise, we will check if A exists in the second map, and the answer is yes, and it maps to P. So again, all is good. We will not do any new mapping. Now comes L, right? And we check it does not exist in the first string, first map. So in this case, we will map it to uh, in this case we will map it to B. But now in the second map, we will check if B exists. If B already exists in the second map, that means there's a remapping. So we will stop here. We will and because uh, in the first map we are adding the string, but in the second map we don't have to edit. That means there is some kind of remapping happening, and we should stop the loop here and just return false as an answer. So now let's jump onto the code. Yeah, so now let's jump into the code. So the first thing, the easiest thing that we can do is we can check for the length of the string. If they are not equal, that means they are not isomorphic. So let's make that into code. Now the next thing we can do is we can start iterating on the string S and T. As the length of the two strings is same, we don't have to worry about different iterators there. What we can do is we can say let C be the character from S and let T be the character from uh, T. So now once we have that, what we have to ensure is like we check if character C exists in the hash map. For that, we have to define the two hash maps, right? So what we can do is we can say let first be the map from let first be the hash map which maps string s to t, right? And then second, what we can do is like we can actually copy paste it and just call it second, right? And this means that this maps characters from t to s. So now what we will check is if first contains key from this character c, that means this character has already been mapped. So what we can do is like we can get these stored from this map, and we can say, okay, get me the first, get me the corresponding mapped value from first, and now if it's not equal to d stored, d is not equal to d stored, in that case we will just return false. Else, else I think it's okay. Nothing is wrong because then we can just continue. And now let's get to the else condition of if first does not contains the character C. In that case, what we will do is like we will put that character with D inside the map in the first character. Now what we have to do is like we have to do the similar check. Like we have to get like a C stored, right? Um, and that C stored should be equal to C stored should. So there are two ways to solve it. Now we can also do is like that C stored should be equal to C. That is the intuitive point. But let's think about it. Like, should this character be should if C was never mapped to D, that should be the case that D should not have been mapped to C so far. So the easiest point to check here is like if second contains the key D already in the map, even though C has not mapped to it, that means the string is not isomorphic. The case that we were talking about, apple and Babsi, the two strings, that was the case. So so that's how we can just keep this solution here. And otherwise, what we will do is like we will map uh, character D to character C. And if we couldn't find any case of uh, non-isomorphic string, in this case, we will just return true. Because we would have already returned false otherwise. So yeah, that's the solution. And now let's test it out if that works. Okay, there are a lot of problems. So what it says is that I need to provide the character to it. So let's see. Uh, Seems correct to me, but okay. Ah, I have forgotten new, I think. Okay, that may be the reason. Let's try it out again. Yeah, that was it. So I think yeah, this was a solution, guys. Hope you liked it. Peace. Thank you.